it was possible.
Let's go back to where it all started.
Hello, I'm Bharat. I'm one of the co-founders of Skyroot Aerospace.
Hi, I'm Pawan. I'm co-founder and CEO of Skyroot Aerospace.
Both Pawan and I joined ISRO in their biggest center, which is their Rocket Development Center, where we got to work hands-on on their largest rocket India has ever built, LVM-3 Mark III.
At ISRO, we not only got hands-on experience working on complex rocket technology, but we also got the front row seat of the entire space industry. And at that time, SpaceX has proved that space is not only for the governments, private enterprise can come, build new technology, solve problems differently, and build a very scalable, large enterprise. And that inspired us to think, why can't we build a globally competitive space company right out of India? Because India has a heritage of 6 decades in space technology. We have our own rocket technology, one among 7 countries who have that capability. We have a great geography for launching. We are very close to the equator, and we have wonderful infrastructure, launch pads, a great supplier and vendor ecosystem in the country. So we felt it's a wonderful opportunity to actually have our own pie in the global space market by building a competitive, scalable space company from India. Then we quit our jobs and started Skyroot with one mission: to open space for all. Our rockets use cutting-edge technology manufactured at scale. One of the first biggest technology which we used is building the entire rocket with carbon composites, and carbon fiber is 5 times lighter than steel, making the rocket very efficient. And the other technology is 3D printing. So typically rocket engines have hundreds of components, and with 3D printing you can build it just with one component.
And to build all of this, it needs state-of-the-art facilities to design and manufacture these rockets. Skyroot operates India's largest private rocket factory in Hyderabad, spanning over 250,000 square feet. And here, we have advanced equipment and machinery like automated filament binding machine, autoclaves, clean rooms, environmental test facilities, and precision machining facilities. All of this will enable us to manufacture one rocket a month.
At Skyroot, we've been fortunate to have an exceptional set of people, very diverse team. We have people, very youngsters, passing from the top tier colleges in the country to veterans, each of them having 40 years of experience in various fields of building rockets. All our people are driven by the culture of first principle thinking, technical rigor, passion for rocket technology, and fully committed to our mission to open space for all.
Every company has a founding story. And what's interesting about Skyroot is how specific the vision was from the very beginning, and how it has directly led to the rocket stack on the pad today.
And that vision didn't become a rocket overnight. It took years of building the team, the technology, and eventually Vikram-1 itself. Let's see how this all came together.
Suborbital is one thing, but orbit?
There's a weight limit, not just on our rocket, but also on our decisions. The constraints were crystal clear. One mission, 0 room for error.
Traditionally, rockets are made with metals. Metal is great, but carries weight.
To reach orbit with a rocket the size of Vikram-1, we needed strength to weight ratio that metals couldn't offer. Composites are an engineering magic, but building with composites is not that easy. It demands diligence. You take fine strands of carbon fiber, mix it with a special resin, weave them and process it. You get a structure that is stronger than metal at a fraction of weight. Some sections of our rocket needed further strengthening, so we made a sandwich using composites in which 2 layers of carbon composites are bonded on the either side of the honeycomb structure.
And then came a different challenge.
Cork sheets made from bark of oak trees are lightweight with tiny air pockets in them.
And by laying them over a composite structure, we can protect the rocket from the atmospheric heat.
Firepower. That's the heart of the rocket and also the biggest engineering challenge. Let's start at the beginning. Our first stage motor, Kalam 1200. It's our most powerful solid rocket motor, loaded with 30 tons of propellant and can generate a peak vacuum thrust 10 times that of a single Boeing 737 MAX aircraft engine. Our second stage motor, Kalam 250, is loaded with 6 tons of propellant and is optimized for higher altitude. And finally, our stage 3 motor, Kalam 100, which is smallest among the 3, is designed to operate in near vacuum condition.
Rocket's first 3 stages were pure fire and fury, but the last stage, that had to be something else entirely.
Thrust gets you to space, but once there, you need something that you can start, stop, and restart. Pretty much adapt in real time.
To achieve this, we have developed a stage powered by a liquid engine. This stage, which we call the Orbit Adjustment Module, sits at the top of the rocket, and its job is to place a satellite in the exact orbit, not close, but exact. First, our engine, Raman-2, our 3D printed engine, which can be ignited, shut down, and restarted in space. Then there are smaller Raman mini thrusters and cold gas thrusters. They control the pitch and yaw and help steer the stage and fine-tune the path.
Every stage before this was about brute force, but our OAM is about control.
Orbit isn't just conquered with fire alone.
It's achieved with accuracy, with timing, with intelligence. The rocket is not just about power.
There's no pilot, no joystick, but just the intelligence we built into it.
To build this intelligence, we first start with the rocket's trajectory, configuration, and the mission sequence.
Mission design gives us the ideal path to the orbit. So we design our algorithms for the rocket to follow this planned path, while also making smart and efficient corrections in case of any deviation. These GNC algorithms work along with the flight sequence software that decides
when to separate the stage, when to ignite the next, and ultimately guide the vehicle to the intended orbit.
To run and execute these algorithms, we have a flight computer and the electronic modules on board the rocket.
But avionics isn't just about these modules. It's the complex system of sensors, cables, modules, and actuators that run along the vehicle. It's the nervous system of the rocket.
And just like nervous system, each of these systems are complex. For instance, how does a rocket sense in which orientation it is in and where it is headed? So the rocket has a system called the inertial measurement unit, which has an accelerometer, a gyroscope, and a magnetometer.
And how does the rocket communicate with the ground station? Through a telemetry module.
And at the core of this network is the mission computer named Ramanujan. It tells every other module what to do and when to do. It takes input from every sensor, runs GNC and flight sequencing algorithms, and gives commands to the rocket. It is the decision maker on board.
And this decision maker needs to be trained for every possible flight outcome. We connect the sensors, mission compute, and run the flight sequencing algorithm through special simulators at our lab.
And we test for every possibility: loss of GPS, engine underperformance, sudden wind gusts, even sensor errors.
Degree just on paper isn't enough. A perfect plan in the calm air means nothing in the storm.
Before even we could think of the launch day came the unforgiving chapter to prove that every part can survive the test.
Qualification wasn't just one test, it was a campaign.
These tests took place over several months, first at component level, then at system level. Take for instance the Kalam 1200 rocket stage.
The composite structures were put through multiple stress tests to check whether they can withstand the violence of flight. The nozzle actuation was tested separately to validate the vehicle steering accuracy.
The safety system of the motor was validated, and so was the igniter. And only when we were satisfied with the data, we moved to the static fire test. The static fire test was conducted at Sriharikota on 8th of August 2025.
The motor fired for 110 seconds with accurate nozzle deflection of 5 degrees, just as it was designed to do.
Having previously tested second stage and third stage of a rocket, we had now taken a big step towards the launch.
Stage separation is a high drama event, and with added complexity of upper stage nozzle protruding into the spent stage that needs to be pushed out. In May 2025, we put the integrated stages for separation on the test bed at our facility. In just 0.2 seconds, the stage 2 and stage 3 were separated, precisely maintaining that thin margin of few centimeters between the stage 3 nozzle and stage 2.
The payload fairing shields the satellite from atmospheric pressure and heat during the ascent. Once the rocket reaches vacuum, those concerns don't exist, so the PLF needs to be ejected out. As the PLF shell sits at the top of the rocket, they need to be separated away from the OAM, while the two shells also needs to be pushed away from each other. There's a lot of physics at play here, and it all had to be validated on the test bed, which is what we exactly did on June 7th. PLF jettisoning success.
After all that raw power of ascent, it's the quiet, precise push of the OAM that guides the payload into its final orbit. Every major component was rigorously tested. The Raman 2 engine, our primary propulsion element, was tested for its full mission cycle. The Raman Mini and cold gas thrusters, which are used for fine-tuned adjustments and attitude control, were tested thousands of times. Even the avionics were tested and fully qualified, ensuring robust and reliable operation under the harsh conditions of spaceflight. Once all these systems passed these rigorous tests, we integrated and brought them together. The OAM is the mission's maestro, orchestrating tiny adjustments to ensure that everything reaches its intended orbit, giving us a flawless finale.
Test after test, every major system on Vikram-1 had qualified.
And with the successful completion of the integrated electrical test,
Vikram-1 was no longer just under development, and the next destination was clear: Sriharikota.
The moment we reach Sriharikota, everything changes.
In the past, we have been here for the Vikram-S mission.
Now, after 4 years, we are back again.
This is the first time a launch pad at Satish Dhawan Space Center is hosting a private orbital rocket.
The launch campaign activities have begun, and with that, the timelines have also become super real.
Because now we are not preparing for a test, we are preparing for a mission, Mission Agaman.
Agaman means arrival in Sanskrit,
embodying the arrival of Vikram-1, a new Indian rocket in the global space market,
and the arrival of a new chapter of
ये मुख्यमंत्री श्रीमान कुमार स्वामी डी.के. शिव कुमार जी ने कहा है, दो डबल स्टैंडर्ड है यहाँ पे। तो 2 महीने जो उन्होंने समय लिया है, राज्य की जो पक्ष का कहना है, बीजेपी और जेडीएस का कहना है कि यहाँ पे कहीं ना कहीं षड्यंत्र रचा हुआ है, साजिश रचा हुआ है। अभी जेडीएस और भाजपा जैसे आरोप लगा रहे, किसानों के मुंह पर सरकार दबाव लगा रहे, दबाव डाल रहे।
बिल्कुल, तो यहाँ पर किसान को दाल में पक्की बात है कि कुछ काला नजर आ रहा है और भाजपा वहां समर्थन करती हुई नजर आ रही है। अब देखना ये होगा कि डी.के. शिव कुमार की सरकार क्या इन किसानों की आवाज को सुनती है या इनकी किसानों की आवाज यहाँ दबती हुई नजर आती है। ये देखना होगा आगे की जब इस परियोजना को लेकर सरकार क्या कोई एक्शन दिखाती है या नहीं। फिलहाल ज्योति, तमाम जानकारियों के साथ आपका बहुत बहुत धन्यवाद। न्यूज पंच में वक्त तो चला एक छोटे से ब्रेक का, लेकिन ब्रेक के बाद जब लौटेंगे तो गुजरात एटीएस का एक बड़ा एक्शन सामने आया है। आतंक का पर्दाफाश हुआ है क्या, ये सब इस छोटे से ब्रेक के बाद। बने रहिए न्यूज पंच के साथ।
जरा सोच के देखिए, आपके पास कुछ ऐसा है जो आपकी दुनिया बदल सकता है। जानते हैं क्या? आपका अपना सोना। सोना क्या नहीं कर सकता? सोना आपको अपने सपनों का घर दिला सकता है, आपके बच्चों का भविष्य बना सकता है। सोना आपकी हर इच्छा पूरी कर सकता है। तो भारत की सबसे बड़ी गोल्ड लोन NBFC मुथूट फाइनेंस से गोल्ड लोन लीजिए और फिर देखिए सोना क्या नहीं कर सकता। मुथूट फाइनेंस, जहाँ विश्वास ही परंपरा है। कॉल कीजिए 1-800-313-1212।
कैसे ले पाएंगे घर?
नहीं, आज गर्मी बहुत है ना?
यस, बहुत ही ज्यादा।
पापा, घर खरीदने की प्लानिंग इज नॉट इजी।
विनी, लॉन्ग टर्म सेविंग्स का बेस्ट प्लान बताना।
LIC प्रोटेक्शन प्लस प्लान।
LIC और सेविंग्स?
यस, इसमें इंश्योरेंस और फंड्स दोनों में इन्वेस्ट करके गोल्स के हिसाब से सम अश्योर्ड एडजस्ट कर सकते हो। LIC प्रोटेक्शन प्लस प्लान, फ्यूचर इंश्योर्ड, ग्रोथ अश्योर्ड।
जब धरती चीर कर निकलता है लोहे का पत्थर और मिलता है मोंगिया के जोश से, फिर तपता है, पिघलता है और बनता है फौलाद। अब होता है सरिया सारी खूबियों के साथ। मोंगिया स्टील, मजबूत देश का मजबूत सरिया।
पढ़ता है, खेलता है, झूलता उछलता है, दौड़ता कभी कभी दौड़ कराता है, आगे आगे बढ़ता है इंडिया, अमूल दूध पीता है इंडिया।
स्वागत है, आप देख रहे हैं न्यूज पंच। आइए अगली खबर का रुख करते हैं। देश के खिलाफ एक बेहद खतरनाक साजिश, आतंक का एक ऐसा जाल जो अगर समय रहते बेनकाब ना होता तो शायद किसी बड़े हादसे की वजह बन सकता था। गुजरात एटीएस ने जैश ए मोहम्मद से जुड़े कथित मॉड्यूल पर बड़ी कार्रवाई करते हुए 5 और संदिग्धों को गिरफ्तार किया है। इसके साथ ही इस मामले में गिरफ्तारियों की संख्या अब 13 हो चुकी है। जांच एजेंसी के मुताबिक आरोपी कथित तौर पर 2023 से बम और आईडी बनाने की ट्रेनिंग ले रहे थे। यानी एक बड़ी साजिश का यहाँ पर्दाफाश करती हुई गुजरात एटीएस और गुजरात में कथित स्लीपर सेल नेटवर्क खड़ा करने की यहाँ एक बड़ी कोशिश को नाकाम किया गया है। शुरुआती जांच में कुछ आरोपियों के पाकिस्तान स्थित जैश नेतृत्व के संपर्क के संकेत भी मिल रहे हैं। फिलहाल सभी आरोपी इस समय पुलिस रिमांड में है और एटीएस पूरी तरीके से इस जांच में लग चुकी है, जहां पूरा नेटवर्क, फंडिंग और संभावित आतंकी साजिश की गहराई से जांच की जा रही है। आइए ग्राफिक्स के जरिए आपको बताते हैं कि देश के खिलाफ ये जो बड़ी साजिश जो है वो कैसे गुजरात एटीएस ने बेनकाब की है और आतंक का यहाँ एक बड़ा नेटवर्क का पता चला है गुजरात एटीएस को। आइए ग्राफिक्स का रुख करते हैं। ग्राफिक्स के जरिए आपको बताते हैं और आपको साथ ही वो चेहरे दिखाते हैं जो इसमें आतंकी साजिश में लिप्त थे। ये देखिए, ये तस्वीरें आप देख रहे हैं, तस्वीरें गुजरात एटीएस के बड़े एक्शन के बाद इन 5 और संदिग्धों को यहाँ गिरफ्तार किया है, जहां पुलिस रिमांड में इनसे पूछताछ की जा रही है और कई खौफनाक परतें यहाँ खुलती हुई नजर आ रही है। पाकिस्तान कनेक्शन की भी यहाँ बात कही जा रही है। कहा जा रहा है कि एक बड़ा नेटवर्क ये था और एक बड़ी साजिश करने की योजना बना रहे थे और अभी से नहीं, 2 साल से ये योजना बन रही थी। जैश के टेरर मॉड्यूल का यहाँ बड़ा पर्दाफाश, गुजरात एटीएस की बड़ी कार्रवाई यहाँ हुई, जहाँ भारत के खिलाफ रची जा रही बड़ी साजिश को यहाँ नाकाम किया है। ये वो चेहरे हैं जो भारत में आतंकी नेटवर्क फैला रहे थे और इनका कहीं ना कहीं लिंक पाकिस्तान के जैश नेतृत्व से भी किया जा रहा है। साथ ही आपको बता दें कि आतंकी नेटवर्क पर जो शिकंजा कसा है वो कथित तौर पर आपको बताएं 2023 से ये बम और आईईडी ट्रेनिंग ली जा रही थी। आइए आपको सुनवाते हैं यहां पुलिस की तरफ से क्या जानकारी मिलती हुई नजर आ रही है।
शॉपिंग पोर्टल और लोकल मार्केट से कुछ केमिकल्स खरीदे थे जिनमें कि मेनली पोटेशियम नाइट्रेट, सल्फर, चारकोल था। इनका एक फिक्स रेशियो में मिला करके गन पाउडर इनके द्वारा तैयार किया गया था। ये इनको डेटोनेट करने के लिए अलग अलग तरह की मैकेनिज्म पे काम कर रहे थे। इसमें